Hey everyone, welcome back to my YouTube channel. I am Ved Prakash, and if you are new here, do not forget to hit the like button and subscribe for more coding tutorials and problem solving guides. Today we are solving a really interesting binary tree problem called longest zigzag path in a binary tree. In this problem, we have been given a root of the binary tree, and a zigzag path can be defined as starting from any node in the tree, and we can pick a direction, either it is left or right, and then move in that direction and then switch to the opposite direction at the next step. For example, like we have picked this node and then we selected to go to the right, and then in the next step we have to go to the left, and then again we have to start from right. Okay, and we will keep doing it until we are not able to move further. And the zigzag length can be defined as the number of edges we have passed till now, or equivalently nodes visited minus 1. For example, in this path we have visited 3 edges and 4 nodes. So either it can be number of edges, that is 3, or it can be number of nodes minus 1, that is 4 minus 1, that is also 3. And our goal here is to return the longest zigzag path in the tree. So in this example, we can see that we picked this node and then we went to the right, and then in the next step, according to rule, we have to move to the left, and then again we have to move in the opposite direction of the previous direction, that is left, and left opposite of left is right, so we will be going to right again. And here we can see that it is 3 only. A brute force approach should be starting from any node, and then we will explore in both left and right directions, and we will be recursively alternating. We will track the maximum zigzag length, but this would be too slow, especially since the number of nodes can go up to 50,000. It will be too slow. So instead what we can do is that we can solve it efficiently using depth first search, DFS. So here is the key idea. At every node we explore two possibilities: continue zigzag to the left or continue zigzag to the right. And while exploring, we will keep track of the current length of the zigzag length and the direction we just came from. Okay, so let's implement this one. First of all, we will define self dot max underscore length is equal to 0. Okay, and then we will define a helper function DFS, which will take node comma direction comma length as input. Okay, and here we will check if not node, that means if there is no tree, then we will return none. Okay, and then again we will update self dot max underscore length equal to max of self dot max underscore len comma length. Okay, and then we will check if direction is equal to left, then we will move in the right direction, node dot right comma right comma length plus 1, and then we will restart from left, that is DFS of node dot left comma left comma 1. Okay, and else, in the else condition we know that if it was not left, then it would be right. So in the else condition it is right, so we will move to the left. So DFS of node dot left comma left comma length, we will increase the value of length by 1, and then again we will restart from right, that is node dot right comma length comma right comma 1. And for example, if we are starting from root, then we can just root dot left comma left comma 1, and then DFS of root dot right, comma, right, comma 1. I think I forgot to put inverted comma everywhere because this is a string, not some variable. It would have thrown error. And at the end, we will return the value of self dot max underscore length. So that's the code for our zigzag length. Now let me try to run it and check how if it passes these 3 test cases or not. So as we can see here that our code passes these 3 test cases. Now I will try to submit it and check how does it perform compared to other users in terms of time complexity and space complexity. Time complexity of this solution is big of n because each node is visited at most twice, and space complexity of this solution is big of h, where h is the height of the tree, and that is also because we are maintaining a stack for recursion. So that's how we solve longest zigzag path in binary tree, and we use DFS, tracked the direction and updated the maximum zigzag length along the way. And if you found this explanation helpful, do not forget to hit the like button and subscribe to my YouTube channel. And uh, thank you for watching, and see you in next video.